Okay, so my dear students from Begum Roka University, Rangpur, I'm really delighted to give a lecture today in the topic of multicollinearity. So, this is one of the most important topic in econometrics. For econometric data analysis, you might face a lot of problems when you are gonna analyze your data. So one of the most common problem is multicollinearity. So today we'll try to give you some idea or glimpse of idea by which you can have some good idea about multicollinearity problem. So what is multicollinearity? Or if you are asked to define or the nature of the multicollinearity, I have to say like, one of the basic assumption of the multiple linear regression model is that there is no perfect linear relationship among the explanatory variables, right? So you have to revisit the assumption, basic assumption of the classical linear regression model. What is those assumptions? One of the most important assumption is that this assumption, you can take a look like, there are no perfect linear relationship among the explanatory variables. So you have to keep in mind that there are no perfect linear relationship among the explanatory variables. As the name suggests, as the independent variables or the predictors are independent, right? So as the name suggests, it's a normal thing that there is no perfect relationship or linear relationship among the explanatory variables or independent variables, right? This is the most common thing. But if you find the violation of this assumption, like if you can find the perfect linear relationship among the explanatory variables, right, then the problem begins. And this problem is nothing but the called multicollinearity problem. So if such an exact linear relationship does exist, we can say that the independent variables are perfectly collinear, or that perfect collinearity exists, right? So I again repeat, if there is exact linear relationship among independent variables in your regression model, right, then you might suspect that there is a perfect multicollinearity or there is a perfect collinear variables there. So the collinear variables are independent variables there, right? So this is a problem, and this problem is called the multicollinearity problem. So when multicollinearity arises when two or more variables or combination of variables are highly correlated with each other, right? So if I can define multicollinearity, then maybe the definition would be like this. That term multicollinearity means the existence of a perfect or exact or linear relationship among some or all explanatory variables of a regression model, right? So if you are running a regression model, first you have to check whether there is an existence, right? Existence of what? Existence of a perfect or exact or linear relationship among some or all explanatory variables of a regression model, right? So this is the message from me, like what is multicollinearity. So you might suspect a multicollinearity in your regression model if you find the existence of a perfect or exact or linear relationship among what? Among some or explanatory variables of a regression model. So multicollinearity occurs when independent variables in a regression model are correlated. Okay, so you students sometimes might face difficulty in your Viva board or like in an exam, you are usually asked, what is multicollinearity problem? Then you can just define like this. Multicollinearity occurs when independent variables in a regression model are correlated, right? So when you will find the independent variables are correlated in a regression model, then you might suspect that there is a multicollinearity problem. So what is the problem? If you can find multicollinearity problem in a regression model, really it makes it hard to interpret of model and also creates an overfitting problem, right? So when you will have multicollinearity problem in your model, then you might face a lot of problems. The problems, of course, because you are estimating the regression model, and the problem will be based on the regression parameter you are going to estimate, right? So you will find very hard to interpret of your model. And also, you can face the overfitting problem. You know, I think there are two problems in the data pattern, or when you are going to estimate your model, there are many problems like overfitting problem or underfitting problem, right? So when you have multicollinearity problem in your data sets, one common problem is the overfitting problem, right? Overfitting problem is the like the suddenly the peak of your data set. Consider the COVID-19, right? Like in 2020, the COVID-19 was like very high peak. Then 2020, the pattern is almost similar, but 2022, now the COVID-19 cases are very low, right? And maybe in future, we don't know really. So consider the overfitting problem. Consider 2 years is here. One is 2022 and 2022, 2020 and 2022, right? If you consider the pattern of 2020 and 2022, 2020 is really a big pattern, like suddenly a huge peak in the data sets. Like this kind of problem is called overfitting problem, like your model is overfitted, right? So this kind of problem might you face when you have multicollinearity in your data sets. Anyway, so what happens if you have multicollinearity problems? So there are many questions of this question. There are many answers of these questions actually, right? What might happen if you have multicollinearity problem in your data set? So what are those? So multicollinearity reduces the precision of the estimated coefficient, right? So as a statistician or as a regression modeler, what is your objective? What is your goal? What is our aim, right? We need to have some precise estimate. That means a very good estimate of the regression model. But if you have multicollinearity problem in your regression model, then precision is a difficult task. The estimated parameters like the coefficients or the parameter of the regression model is no longer efficient. So why it happens? Because your data might have multicollinearity problem, which weakens the statistical power of the regression model. So I always tell you, when you are going to estimate your model, the basic thing is that you have to validate your model. Suppose you have the data, no problem. You can run your model based on the data, no problem. But after having the estimated parameters of your regression model, the most important thing is that you have to check the assumption of the regression model. Also, the most important thing is here, you have to check the validity of the regression model. Without a valid regression model, your interpretation might be misleading, right? So what happens if you have multicollinearity problem in your regression model? So there are a lot of problems. The problems is like, you might have the unprecise estimated coefficients or regression parameter from your regression model, or the statistical power of the regression model is not that good. That means you might have the weak statistical power of your regression model. Then what problems? The problem will be many things. You cannot predict your data efficiently, right? So this kind of problem you might face when you have multicollinearity problem in the regression model. So also, you might not be able to trust the p-values, right? To identify independent variables that are statistically significant. So maybe the regression model you can find the significant p-value. That means you can find the significant variables. but literally those significant variables are not really significant. That means the p-value you are gonna get might be misleading, or although the p-value is showing you these particular variables like is significant, but literally they are not significant. So you might face the misleading of the p-values, right? So these are some of the things you might face problem. So where the problems you might face, the main problem you are gonna get in the estimation of the parameter, right? The coefficient, like the alpha, betas, right? These are going to be unprecise, and if you get the unprecise estimated parameters or coefficient, right, your statistical power of your model is no longer powerful, right? So as a statistician, we always looking for a powerful test, like whatever you use as a statistical method, right? So your method must be powerful, but the problem is that when you have multicollinearity problem, the power of our model is a problem. Okay, so what you have to do? Nothing, just you have to remove the multicollinearity problem from your data set, right? So yeah, these are the some of the common like consequences, I would rather say, or some of the common problems you might face when you have multicollinearity problems. So I asked some of the students are here, could you please repeat what is multicollinearity problem? Hello. I asked some of the students, could you please repeat the definition of multicollinearity problem?
Yes, sir.
Proceed.
Sir, if the independent variable are correlated with each other, then there happen multicollinearity.
Yeah, could you please give one example, like the practical example?
Sir,
It's a difficult
no,
question.
Yes, sir.
No problem. You can just Google it, okay? And we'll let you know what are the practical application, right, of multicollinearity problem. So you might face a lot of, like you might experience a lot of practical applications, right? It's not that difficult, like a lot of problems around you. So you can select some variables. Maybe those are the economic variables or economic problem, right? Where naturally or normally the independent variable, you might face a lot of correlations up there, right? So maybe you can set many examples, but we'll take a look later on. What are the most common examples or application of multicollinearity problem, right? But yeah, thank you, Sujana, and your like answer is perfect. So the question was, what is multicollinearity problem? So I repeat it again for you. So what is multicollinearity problem? In a regression model, the multicollinearity problem is like that when independent variables are correlated, right? So this is the most common and very easy definition of multicollinearity problem. I repeat again, when independent variables are found to be correlated in a regression model, then a problem occurs. And this problem is called multicollinearity problem. In mostly the econometric data, right? Multicollinearity occurs. Okay. So anyway, let's proceed. What are the sources of multicollinearity? Like where you can find the multicollinearity problem normally? What are the sources? Suppose there is a tendency for economic variables to move together over time. Like if you consider GDP, GNP, GNI, right? Or the economic stability of a country, the normal tendency of the economic variable is that it's not constant over the time. It's changing, right? So this kind of economic variables are like supposed to be have multicollinearity problem. Could you please explain this problem? Anybody can explain why there is a normal tendency to have multicollinearity problem in the economic variables? Anybody can explain why? I'm telling you there is a tendency for economic variables to move together over time, because the variables in econometric analysis like GDP, GNP, or like the economic pattern of a country normally is not constant over the time. And this is the reason why multicollinearity normal occurs in economic variables. I ask you, can you understand this point or not?
Sorry, sir. Repeat it. I cannot understand it.
Okay, so like the economic stability. So I told you the economic stability does not mean you have to consider only one variable. There are many variables that might affect the economic stability of a particular country, right? Suppose the economic stability depends on many variables. Or what is the economic measurement for a particular country? Could you please give me some example, like what are the economic stability depends on some specific variables? Could you please give me some example?
GDP is economic variable.
I told you the economic stability. What are the factors that might affect the economic stability of a country?
Sir,
Sir, money inflation rate.
Hmm?
Sir, money inflation rate. Or sir,
It's like the foreign remittance, employment, maybe employment opportunities. Like there are a lot of things. I can give you some example like this, the foreign remittance. So Bangladesh, the economy of Bangladesh is going to be good if the foreign remittance come in a constant way or increasing pattern, right? So this is one variable. So what are the other variables?
স্যার আমাদের দেশের মানুষের হচ্ছে গড় ইনকাম
Try to speak in English. I told you again. So it's like the exchange rate, maybe one of the factor. Tax rate, maybe one of the factor. Inflation, maybe one of the factor. Labor, maybe one of the factor. Demand or supply, maybe one of the factor. Law and policy, maybe one of the factor, right? So many things like can affect your economic status of a country. And don't you think what I told you, I gave you many examples, right? So don't you think some variables, so what is the outcome variable here? We want to predict or estimate the economic growth of Bangladesh. Clear? What is the outcome or the dependent variable is here? The economic growth or economic stability of our beloved country, Bangladesh. So this is the dependent or outcome variable, but I want to estimate or I want to see what factors affecting the economic growth or economic stability of our country. So what are those factors? I told you already, like the interest rate, maybe the foreign remittance, exchange rate, tax rate, inflation rate, labor opportunity, maybe demand or supply or wage rate, law and policies. So when the problem multicollinearity occurs here, can you give me an example here? Stop your microphone, please. I told you many times.
Sir, if we consider demand and supply, then there
Good.
occurs multicollinearity because demand and supply are related and they both are independent variable.
Yeah, Kanis, right?
Yes, sir.
So it's very good. Yeah, so you are very perfect. Like, yeah. So what is our problem here? We are going to estimate, right?
Production. We are going to estimate the production.
No, we are going to estimate the economic growth of a country, right?
Yes,
Or
sir.
the economic stability. But when you are going to estimate or predict, right? Or calculate something, you have to consider some of the predictors or factors. Which predictors or factor might affect your economic growth or economic stability, right? So I consider many factors are here. So some of the factors like demand and supply. So yeah, there is an economic theory in econometrics is that there is a relationship between demand and supply. Normally, what is the relationship, Kanis? Could you please explain a little bit more?
Sir, it can be positive relationship.
So yeah, positive and linear maybe, right?
Positive and linear relationship.
But in multicollinearity, it's very important. You have to find a linear relationship, right? Just normal relationship is not, I think that it's not a big problem, but you might have to consider like a perfect linear relationship. Anyway, your example is quite fit, right? Quite good fit to our example. what are the sources of multicollinearity? So what is the message from our first slide? The message is normally in economic variables, because economic variables tends to move over time. It's not constant over the time, because there are a lot of problems going on right around the world nowadays, and there is war, Russia and Ukraine, right? For the Russia and Ukraine issue, our economic stability is not stable nowadays, right? So mostly in the economic variables, the multicollinearity problem might occur, right? So the next one is the use of lagged values of some explanative variables as separate independent factors in the relationship. So can you understand this point? The use of lagged values of some explanatory variables as separate independent factors in the relationship. Can you explain someone, or can you understand this point or not?
No, sir.
So lagged value means, suppose, can you hear me?
Yes, sir.
Yes, sir.
Suppose you have income today, and what was the income of you in tomorrow? There was a definite income. What do you think? Isn't it? You had an income yesterday, of course, or day before yesterday, or last month. The lagged value means the previous value comparing the current value, right? So in the lagged values of some independent variables, when you are consider those variables as separate independent variables, normally in this kind of relationship, you might face the problem of multicollinearity, right? Anyway, we can explain it later on. So, and the data collection method, data collection is very important in statistical data analysis or maybe interpretation, right? And for the faulty data collection, or if you have some problem in the data collection, you might face the multicollinearity problem. And there are many constants like the regression of the electricity consumptions. I can give you one example, like if you want to run a regression model on electricity consumption, on income and house price, right? So my dependent variable is here electricity consumption. And what is the independent variable? Income and house size. So these are the factors that might affect your electricity consumption. So there is a physical constant in the population in that families with higher income generally have larger homes than family with lower income. So what is the interpretation here? There might a linear relationship between your income and house size. So there might suspect, or you can suspect a multicollinearity problem in this example. This is a perfect example. Here, you can fit, or you can ask, or you can like give the answer where multicollinearity occurs. So this is a perfect example. So what is the examples? I repeat again. If you want to estimate the electricity consumption on income and house size, so what is the dependent variable here or outcome?
Electricity consumption outcome.
Very good. So what is the predictors here, or what are the predictors here?
Income.
Income and
Income
house.
And house.
Okay, so normally there might have correlation between income and house size. Why? Because normally when your income increases, right? What is your intention then? Normally, the rich people used to have larger house, right? So there is a positive linear relationship between income and house. But if this is a collinear variables, income and household, right? Household size. So if you put these collinear variables in the regression model, then you might face many problems. So the problem is nothing but the multicollinearity problem, because this relationship might disturb the electricity consumption. So the true estimation of the valid estimation of the electricity consumption will be misleading, right? So why it happens? Due to the multicollinearity problem. What is the multicollinearity problem here? The multicollinearity problem here is nothing but the collinear relationship or collinearity between income and household size. Although this is a simple regression model, but I don't think here the problem is a very big problem, but when you consider the multiple linear regression model, the problem will be much problematic in the like multiple linear regression model. Anyway, so the model specification, I told you many times, in a regression model, you have to specify your model correctly. Okay, specification means like the independent variables, you have to put in the independent variables. You cannot use the independent variables as a dependent variable, right? So that will give you a misleading result. Model specification, that means you have to correctly specify your model. That is very important. Without correct specification of the regression model, you cannot like expect some of the good results from your regression model. So if your intention is to estimate the regression model correctly, right, then model specification is very important. Model specification means you have to specify all the variables correctly. That means the dependent variable, you have to put in the dependent variable. You cannot use dependent variable for independent variables, right? Or vice versa, you cannot use independent variable for dependent variable. So these are the things, and you have to estimate your model correctly. Anyway, an over determined model, this happens when the model has more explanatory variables than the number of observations. So I think, can you remember one basic assumption of the classical linear regression model about this sentence? Can you remember one of the, there is one classic linear regression model, there is another assumption of the classical linear regression model regarding this topic, like the number of observation and the number of explanatory variables. Can you remember? Hello.
No, sir.
Why? I told you in the previous classes.
Sir, number of observation cannot be greater than the dependent variable, like that.
No, check it. Just check it. You don't have the like knowledge here, like you don't have the book right now, or the lecture sheet, no?
আর হচ্ছে এটা হচ্ছে the number of observation n must be greater than the number of parameters to be estimated.
Exactly. So the same thing. Annie, could you please tell me how can you find the number of parameters? What is the relationship between number of parameters and number of explanatory variables?
স্যার
Maybe
একটা
Sujan?
কম হবে
Sujana, maybe you can answer this question. What is the relationship between number of independent variables or number of explanatory variables and number of parameters in the regression model?
Beta is always equal to the number of explanatory variables.
Exactly. Like the total number of explanatory variables, that
Equal to
means
the number.
you will find the exact amount of parameters, right? You are going to estimate. So the sentence is here is that when multicollinearity happens when the model has more explanatory variables than the number of observations. And this is a strict violation of the assumption of the classical linear regression model. Don't you think this is a violation?
Yes, sir. Obviously, it's a violation.
It's a violation. That means when your model have more explanatory variables than the number of observations, right? So this is a violation of the classical linear regression model. And for this violation, you might face a problem. The problem is nothing, multicollinearity problem, right? Consider the last line. It's a very important example. In medical research, right? In medical research, there may be a small number of patients about whom information is collected on a large number of variables. Clear? Like the patient number of patients is very low, but we can collect a lot of information from a lower number of patients. Suppose in a hospital, we can find 10 patients, right? But we can collect many information or many independent variables from 5 patients, right? So what are then the problem will be here if you consider explanatory variables and the number of observations. If the explanatory variables is more than the number of observations here, then you might face the multicollinearity problem. In medical research or medical data, multicollinearity problem normally occurs frequently, because in our body, suppose I am gonna investigate particular disease in your body, like you are suffering from a particular disease or not. So what is the outcome here? What is the outcome? The outcome is suffering from a disease. This is the outcome. And what is the response, or what is the type of the outcome here? This is the binary response. So the suffering of the disease will be yes or no. You understand or not?
Yes,
Yes,
sir.
sir.
Suppose my research is to investigate whether you suffers from a particular disease. Suppose you suffers from a lung cancer or not. Lung cancer. So this is the outcome. So in your statistical research, if you use a model or regression model, what will be the dependent variable or outcome variable is here? The outcome variable is here is nothing but the occurrence of disease, right? The occurrence of disease means the probability or possibility of developing a disease of you. So what is the outcome nature is like binary response, yes or no. So the dependent variable will be the categorized dependent variable, yes or no. So what is my research here? To investigate the lung cancer occurrence among third-year students of Begum Rokeya University, Rangpur, right? So could you please give me some explanatory variables, or could you please give me some examples of explanatory variables or independent variables that might affect the lung cancer occurrence?
So smoking.
Sir,
Very good.
smoke, drug addicted.
Smoking status. You have to tell like this, smoking status. So what is the type of the variable smoking status?
Sir, yes
Yes
or no?
or
Yes
no.
and no, sir. Binary.
The binary
Dummy
response, right?
Yes.
Dummy variable. Very good. So this is one variable, and tell me some more variables. Tell me more variables.
Maybe friend circle.
Huh?
Friend circle.
Then that, okay, it's okay, but you have to specify number of friends. Maybe
Number of friends.
number. What is the type of this variable? Number of friends?
Eating habit.
No, I told Kanis, Fatima, what is the type of the variable you just told me? Number of friends.
Sir, quantitative data. Type of, sorry, sir.
It's a quantitative. Yeah, you are correct.
Quantitative data.
But this is discrete or continuous.
Sir, discrete.
This is discrete. Very good. So could you, it's very good example, no problem. Could you please give me more explanatory variables? Because we really want to see the multicollinearity problem in medical data. So we need more explanatory variables, and those variables must be logical, right? So practically you can see a lot of variables. Suppose you are a good smoker, light smoker, or heavy smoker. Light smoker is not that bad, but heavy smoker is a bad thing. Like you are addicted too much to smoking. What factors might affect your smoking status? Could you please give me more examples? So right now I got two explanatory variables for you smoking lung cancer development. Number one is smoking status or smoking habit. Number two is the number of friends, right? What are those other variables?
Sir, maybe
Tell me.
location.
No, it's income is the important one. Income. Normally, if your income is very high, then normally maybe you tends to smoke a little bit more, right? Compared to the lower income students. Okay. So I got now three variables: income, then number of friends, right? And the smoking status. What are those other variables? Anyway, just forget it. There are many variables you can say. So what do you think? Is there, you might suspect a multicollinearity problem here?
Yes, sir, income and smoking habit are related.
Very good. So income might be, income and smoking habits, right, might be linearly related. Like there might have some linear relationship between income and smoking status, and ultimately you will have some problem, like the true parameter estimation is going to be a problem for the lung cancer development, right? Maybe you can find your p-value significant here, but this is not the true significant, because already you have a problem among the relationship for between two independent variables. One is income and another is smoking status. So the overall estimation in your lung cancer outcome estimation will have a problem, right? So these are some problems, right? In medical research, mostly this problem occurs, like the multicollinearity problem. Anyway, so what are the consequences? Like, suppose you have multicollinearity problem in your data set, what are the consequences you might have in your data analysis or modeling? So I already told you many consequences, but maybe like this wrong interpretation of the regression coefficient, right? Sometimes the regression parameter might be very large, which is not supposed to be very large, but you might find that parameter is very large. So large parameter, like illogical large parameter, might be one problem. Although blue means the base linear unbiased estimator, large variance and covariance of the OLS estimate of the regression parameter. Okay, maybe we can find the blue parameter, but originally the large variance and covariance of the OLS estimator of the regression parameter are not valid. Because of the consequences too, I just repeat you, like the confidence interval tends to be much wider, leading to the acceptance of the zero null hypothesis. That means the true population coefficient is zero more readily. So can you understand this point? What do you think? The confidence interval is good when the confidence is smaller or larger?
So larger hole.
I don't think so, huh? Suppose, okay, I want to give some example, like confidence interval. Do you mean, do you know the meaning of confidence interval? How many things are there? Upper and lower limit. Upper
We use
limit
it
and
to
lower.
estimate the unknown parameter.
Yeah, it's okay, but I told you how many things you might see in confidence interval calculation. How many elements in the formula of confidence interval? Oh my God, you cannot remember that formula?
Sir, mean লাগবে variance করবে। আর
No,
total
it's
observation-
not like that. I told you, you will just find only two quantity there. Okay, is the lower limit and the upper limit.
Oh, হ্যাঁ, lower limit and upper limit.
Okay, what do you think? The difference between lower limit and upper limit is wider. Number 1 point. Number 2 point is the difference between lower limit and upper limit is very closer. Which one is good?
Sir, closer one is very good.
Closure.
Closer one is
তো closer হলে হচ্ছে বেশি ভুল।
Closer, right? Closer. Anyway, so try to revisit the what should I say, the background knowledge of confidence interval. You have to know all the things, otherwise it's difficult to like have a good understanding on econometric data. Maybe we can take another class on this topic. Anyway, so because of the consequences too, that means when you have a large variance and covariance, okay, your confidence interval tend to be much wider, and that is not good, right? So this is the another consequences of multicollinearity problem. If you have multicollinearity problem in your data set, right, you might face the larger variance and covariance of your estimated parameters. Also, the confidence interval must be wider, and this is not definitely good. So what are the another consequences? The T ratio of one or more coefficient tends to be statistically insignificant, right? So normally our objective is to see the significance of the parameter to be estimated, but if you have multicollinearity problem, you might see the insignificant variables in your regression model, right? And the T ratio, T is one kind of formula by which you can take the significance. You can take the significance, right, of the parameter. So I told you many times the RS square, right? Normally when you have multicollinearity problem, okay, then you can find the insignificant R square. That means the overall measure of potential fit can be very high, but you cannot even say that the R square is very high. It does not mean sometimes the regression model is still valid, right? I told you, like, normally when you just increase the independent variable, there is a tendency is that normally your R square is getting higher, but this is not the logical thing, right? So anyway, when you have multicollinearity problem in your data set, this kind of problem might occur. Sometimes you might see, okay, the R square is very higher and higher, right? But you have to check whether the independent variables you consider, is there any multicollinearity problem in the independent variables or not, right? So you have to check those things. So the OLS estimate and their standard error can be sensitive to small change in the data, right? So you might face some problem also. The standard error may be very higher if you have multicollinearity problem in your data set, right? So these are the consequences. So if I can summarize, the consequences mostly will be in the parameter estimation. That means your coefficient, your parameter, right, will not be logical. It will be insufficiently large. It will be not valid, right? The R square pattern will, like, definitely say illogical pattern, maybe very high or very low, right? A confidence interval may be much wider, and maybe the large variance and covariance you definitely get if you have multiple collinearity problem in your data sets. Okay, so these are the consequences. So the next important thing is that how can you detect multicollinearity problem, right? How can you detect multicollinearity problem in your data set? The number one is high R square but few significant P ratio. Suppose you have a data set, okay, and you calculate it, or you analyze the data for your particular data set. So you found high R square but very few significant T ratio. That means overall the regression model is very good or valid, but suppose this is a regression model, y is equal to alpha plus beta 1 x1, okay, beta 2 x2 up to beta 5 x5. So overall you found here the R square is very high, like 0.99. Okay, what does it mean? R square is 0.99. What does it mean?
So it means the model is well fitted. The model is very,
Very
well
good.
fitted.
Yeah, the model is very good fitted. Anyway, you can find R square is very high, but very significant predictor. Like how many predictors are here in this example or in the regression model?
5.
5.
Hi,
So
sir.
like out of 5, you find very few significant variables. What is significant variables? Do you understand or not? How can you
Yes,
taste
sir.
x1 is a significant variable, x2 is a significant variable, x3 is a significant variable? How can you taste?
So we can test it a dependent
with
variable and
example,
take one by one independent variable, and we check the linear relationship or collinearity between.
This is the basic, but how can you test? So what test you can use for this significant relationship individually? No problem, you are correct.
The T-test. Usually
Very
T-test,
good.
sir.
Okay, so now you understand this fast detecting method or not?
Yes, sir.
It means you might get high R square in the regression model. This is a good, but the problem is that you might get few significant variables. Okay, so what is the logic behind R square? You might get high R square. What does it mean? It means most of the variables are significant. Isn't it correct? High R square means is that your model is good fitted. Why you say your model is good fitted? Because most of the independent variables can explain the variations in your dependent variable, right? That means the variation in the independent variable can be well explained. That means 99% variation you can explain due to the independent variables. That means the independent variables, right? Most of the independent variables are significant. That means your R square is high, then your R square is high. This is normal thing and this is a good thing. Okay, but most of the time in econometric data or maybe in medical data, you might get high R square, but mostly you might get few significant variables. That is not correct. Then the problem begins. And this problem is called the multicollinearity problem. So how can you detect multicollinearity problem? Suppose you have medical data or you have econometric data, then you can calculate R square. Suppose you get high R square value, but you also get few significant variables, right? Then you might suspect that there is a multicollinearity problem. Okay, this is the first thing. And the second one is high pairwise correlation among the regressor. Regressor is nothing but the predictor. Regressor is nothing but the independent variable, right? So you can test the high pairwise correlation. Do you know the pairwise correlation?
Yes, sir.
Yes, sir.
No. Pairwise means between two variable. Pair. What do you mean by pair?
Yes, sir.
It's a
Two,
two
sir.
tuple.
Pair মানে
variable.
তো দুটা variable।
Okay, so suppose you have like x1. Oh, sorry. You have x. I can write it. I don't know what problem. Okay, suppose you have 5 or 6 variable, right? So you can test the pairwise correlation. Pair means suppose you have x1, x2, x3, x4, x5. You can do the pairwise means x1 with x2, x1 with x3, x1 with x4, right? Or maybe x4 with x1. So there are a lot of combinations, right? So you can check the pairwise correlation, and if you can find the linear relationship, right? In the pairwise correlation, you might suspect there is a multicollinearity problem. So you can also see the partial correlation. What is partial correlation?
There will be so many independent variables that are correlated.
Exactly. The logic is something like this, but maybe you can test it later on. Okay. It's not a bad problem, but that's why you need to have some very good knowledge for a bit of anyway. And auxiliary regression. What is auxiliary regression? Anyway, for the time being, maybe we can discuss it later, but try to know what are the detecting methods, right? Then eigenvalue and condition matrix for tolerance and variance inflation factor. So for the time being, I'm going to be very quick, but maybe in the next class, in the practical, we can be very in brief about the description of these topics. So if I ask you what are the different methods, right? So somebody, could you please like repeat? I'm showing you the slide. Just tell me what are the different methods of detecting multicollinearity problem. Number one, tell me something. Tell me anybody.
High
Number one.
I square and T ratio.
It's not complete.
Sir, high
Tell me again.
pairwise correlation among the regressor.
Take a look in the slide.
So high R
Just-
square but few significant T ratios.
Very good. Number two.
High pairwise correlation among regressors.
High pairwise correlation among the regressor.
Number three.
Examination of
Examination
partial
of
correlation.
partial correlation.
Number four.
Auxiliary regression.
Number five.
Eigenvalues and condition index.
Number six.
Tolerance and variance
Variance
inflation
factor.
So these are the common different methods for detecting multicollinearity problem, right? So maybe we can discuss it later when we'll do the practical things. Okay. So these are some of the things, the explanation, right? Explanation. I already explained throughout the different examples. Maybe I don't need to repeat it, right? Just take a look. High R square but few significant T ratio. So this is the first detection method you can use if you want to suspect multicollinearity problem in your data sets. You can also see the high pairwise correlation among the regressor, right? So you can just take a look here. So there are some mathematics behind here. So these are nothing but the mathematical notations. I don't think these are very complex. These are really a very simple mathematical formulation. So you can also examine the partial correlation, right? to detect the multicollinearity problem in your data sets. You can use the auxiliary regression, right? You can take help from auxiliary regression to detect multicollinearity problem in your data sets. So this is very important. So I will focus this one. What is this topic? Eigenvalues and condition index, right?
Yes,
So
sir.
you can use eigenvalue and condition index. And what is the rule of thumb? And can you remember eigenvalue in a matrix? Can you remember?
Yes, sir.
Or how can you calculate the eigenvalue in a matrix?
Lambda.
Sir, suppose that A is a matrix, A minus I is equal to 0. When
Okay, no
we
worries,
get-
no worries, no worries. Because we will use the programming, okay? So when you will have the data, you can just write some programming codes. Then you will have the condition index and eigenvalue, like a lot of things, okay? So just try to remember here, what is the formula? So I told you there are two methods are here. One is eigenvalue and one is condition index. So
Yes, sir.
what is K here? K is nothing but the condition number. So how can you calculate condition number? K is equal to, in the numerator, maximum eigenvalue, in the denominator is the minimum eigenvalue. So you have to find maximum eigenvalue and the minimum eigenvalue. Then the condition index will be calculated. K, just you have to take the square root, okay, over the row, over the K. You understand? How can you calculate the condition index?
Yes, sir.
Just we have to find the maximum eigenvalue. We have to find the minimum eigenvalue, right? So then you have to square root over the K. K is nothing but the condition number. Okay. So what is the detection of multicollinearity? Suppose you calculated the condition number. A large condition number indicates the existence of multicollinearity problem. You understand? A large condition number, but there might have many questions. So what is the number or what is the maximum number? But we can try to explore it later. But right now you have to remember that how can you detect multicollinearity problem? A large condition number indicates that there is the existence of multicollinearity problem. But I can give you the more explanation. If K is between 100 and 1000, there is moderate to strong multicollinearity. I repeat again, if K is between 100 to 1000, you can conclude that there is a moderate to strong multicollinearity. But if it exceeds 1000, you have to conclude that there is a severe multicollinearity problem. So here you are using the condition number. Can you just repeat somebody? What is the rule of thumb here for the condition number?
If condition number is between 100 and 1000, then it's occurred moderate multicollinearity problem.
Moderate to strong, moderate to strong.
Moderate to strong. And if it exceeds 1000, then it becomes severe multicollinearity.
Exactly. So this is the based on the condition number. You can use condition number to check or to detect a multicollinearity problem in your data set, right? Economic data set. But what's about the condition index? How can you calculate the condition index? I gave you, like I told you, like 3 or 4 sentences back. You already know how to calculate the condition index, right? So I told you now, like, what is the rule of thumb if you can use condition index to detect multicollinearity problem? What is the rule of thumb? Number one, this one, when the condition index is less than 10, it means there is no multicollinearity problem in your data sets. Here, when the condition index ranges from 10 to 30, it means there is a moderate multicollinearity problem. If the condition index is greater than 30, it means there is a severe multicollinearity problem in the data. Here, so Please repeat somebody, like what is the rule of thumb for detection of multicollinearity?
Yes, sir.
Yeah, tell me.
If the confidence index is less than 10, then it is called the no multicollinearity. And if the confidence index is exists between 10 or 30, then it is called the moderate multicollinearity. And if the confidence index is greater than 30, then it is called the severe multicollinearity.
Very good. So the answer is like you can detect multicollinearity problem using two measures, two index, or one is condition number, one is condition index. So if you consider the condition number, so you can conclude like this. If you can denote the condition number by k, if k is between 100 to 1000, that means there is a moderate to strong multicollinearity. But when it exceeds 1000, you have to conclude that there is a severe multicollinearity problem, right? You can also use another measure, it's called the condition index. If the condition index is less than 10, it means there is no multicollinearity problem. If the condition index ranges from 10 to 30, you can conclude that there is a moderate multicollinearity. But if the condition index is greater than 30, it means there is a severe multicollinearity problem, right? So this is one of the most important detection process by which you can detect multicollinearity problem in econometric data or maybe medical data. Clear? Good. So another one is the tolerance and variance inflation factor. So what are the rule of thumb here? If the variance inflation factor exceeds 10, that time or then R square also exceeds 0.9. So this is a correlation, like it's not correlation really, but if you can find the variance inflation factor, also you can check the R square then. Normally the R square is also higher there, like 0.9. Then the variable is said to be highly collinear. Clear? So when you have variables, you can just find the variance inflation factor. And if the value of the variance inflation factor is exceed 10, that time automatically you will see also the R square also exceeds 0.90. Anyway, you can just calculate variance inflation factor. Then you will find, or you can say that these two variables are highly collinear, right? One or more large variance inflation factors indicate multicollinearity problem. Okay, so these are the interpretation for variance inflation factors. What about the tolerance values? The tolerance values are defined as the inverse of variance inflation factor values. Okay, so once you can calculate the variance inflation factor, how can you calculate the tolerance value then? Answer me.
1 by
Suppose-
VI.
1 by VI.
Okay,
Variation.
exactly. That's the inverse of the variance inflation factor, right? So no problem, we can find it later on. So what is the interpretation of tolerance and variance inflation factor? So since tolerance values are inverse of VIF, right? That means low tolerance value indicate a multicollinearity problem. Clear? So we got two measurements here. For the variance inflation factor, if it exceeds 10, you can suspect multicollinearity problem. But what about the tolerance? Low tolerance value, because you are taking the inverse of the variance inflation factor, right? So when the lower tolerance value, you will find, then you can say you have a multicollinearity problem in your data set, right? So, but what are the values then? The closer is tolerance to 0, the greater the degree of collinearity of that variable with other regressor, right? On the other hand, the closer the tolerance to 1, the greater the evidence that X is not collinear with the other regressors, right? So the range is tolerance limit, the range of the limit is 0 to 1. If the tolerance value closer to 1, it means there is a high degree of multicollinearity. But if the tolerance limit close to 1, it means there is a lower possibility of multicollinearity problem. You understand? So the message is very clear from this slide. Suppose how many measures we can use here in this slide for detecting multicollinearity problem? There are two measures. One is variance inflation factor, another is the tolerance limit. For the variance inflation factor, if it exceeds 10, then you can say there is a multicollinearity problem. But for the tolerance limit, normally the tolerance limit will be lower compared to the variance inflation factor, because for the calculation of tolerance limit, right, you can just take the inverse of the variance inflation factor to calculate the tolerance limit. So what is the condition of tolerance limit? Like, it ranges from 0 to 1. If it is close to 0, you might suspect the higher multicollinearity problem. If it is close to 1, you might suspect like there is no multicollinearity. Okay, so this is the like interpretation of knowledge we just got from this slide. So what is the rule of thumb? No question, just take this slide, you will understand. So if the variance inflation factor is less than 5, what does it mean? It means there is no multicollinearity. Mute your microphone, ID 39. If the variance inflation factor ranges from 5 to 10, it means there is a moderate multicollinearity problem. If the variance inflation factor greater than 10, it means there is a severe multicollinearity problem. You got it? If the variance inflation factor less than 5, it means mute your microphone. If the variance inflation factor less than 5, it means there is no multicollinearity problem. If the variance inflation factor ranges from 5 to 10, it means moderate multicollinearity problem. Mute your microphone. ID 39. If the variance inflation factor greater than 10, it means there is a severe multicollinearity problem. Here?
Yes, sir.
Mr. Shojal, you can also mute the microphone of others. You have the right now. You are the co-host. So for the tolerance limit, like if the tolerance limit greater than 0.2, it means there is the multicollinearity problem. If the tolerance limit less than or equal to 0.2, there is moderate multicollinearity. If the tolerance limit less than 0.1, it means there is a severe multicollinearity. Okay, repeat. Somebody please repeat. What is the rule of thumb for variance inflation factor and tolerance limit?
If VIF less than 5, no multicollinearity. If 5 less than equal, VIF less than equal.
If VIF ranges from 5 to 10.
Yes, sir.
Then
it's called moderate multicollinearity, and VIF range greater than 10, it's called several multicollinearity.
what about the tolerance limit? Tolerance limit.
Tolerance limit
is greater than 0.2, then there is no multicollinearity. If it is less than or equal 0.2, then it is called the moderate multicollinearity. And if it is less than 0.1, that is called the severe multicollinearity.
Great, perfect. So the next question is, suppose you have multicollinearity problem. This is good or bad? Suppose you have multicollinearity problem in your data set. This is good or bad?
Bad.
Bad.
Really bad. So you have to remove the multicollinearity problem, right? So
Yes, sir.
could you please tell me, anybody, like how can you remove the multicollinearity problem from your data set? Just tell me from your logical sense.
One is if the
Removing independent correlated variable.
Yeah. You have to remove the
variable,
yeah.
we can remove the high correlated independent variable from the data set.
Exactly. So yeah, you are perfect. Like, yeah, you can do this, but there are many other techniques also. A priori information. Priori means priori. Maybe you can pronounce it priori. Priori means the previous knowledge. You can also use the previous knowledge in your model. Then you can combine the cross-sectional and time series data. Okay, you can combine the cross-sectional and time series data. You can drop a variable, and like the high collinear variable you can drop, and you can remove the specification bias. I told you many times. you can transform the variable, right? Suppose your data pattern is not good, but you can transform the data for the logical interpretation. Then you can add additional or new data. Suppose all the variables you found insignificant, right, in your model, although your model shows the high R square. Clear? So this is not good, but you need a significant variable because your objective is to estimate something, definitely. You can additionally add new data, new variables. And reducing collinearity in polynomial regression. In polynomial regression, mostly like the multicollinearity occurs, then you can reduce the collinearity in the polynomial regression. There are some other methods also. There are many methods of multicollinearity problem, like the data collection method. Mostly in the for the faulty data collection, you might face the multicollinearity problem. So for the data collection, you have to be very aware. For the data collector, they need to be trained. You have to make training for the data collection tools. Anyway, so this is the end of today's class, and our class was about what? About multicollinearity problem. Wait, I cannot.